Surds. Rational and irrational numbers. Rational numbers are numbers that can be expressed in the form of a over b, where a and b are both integers and b must not be 0. Consider the following numbers: 1 over 3, 0.92, and 1 and 2 over 5. Each of these numbers can be expressed as a fraction, that is 1 over 3, 92 over 100, and 7 over 5. Numbers that cannot be expressed in this form are called irrational numbers. For example, pi, root 5, and so on. When irrational numbers are expressed as decimals, the decimal continues without an end and without a recurring pattern. For example, pi is equal to 3.141592, root 5 is equal to 2.236067, and so on without an end. The roots of rational numbers that give irrational numbers are called surds. For example, in root 5, 5 is a rational number, but its root, that is 2.236067, is an irrational number. Note that the mere presence of a root sign does not necessarily indicate that that number is a surd. For example, cube root of 8. 8 is a rational number, but we said for a number to qualify as a surd, its root must be an irrational number. Cube root of 8 is 2. 2 is a rational number, and therefore the cube root of 8 is not a surd. Root 49. 49 itself is a rational number. Root 49 is also not a surd because the square root of 49 is 7, and 7 is a rational number. Fifth root of 32 is 2, and therefore fifth root of 32 is not a surd. Next, simplification of surds. Now, for a surd of the nature root xy or root x over y, we can also write them as root x times root y or root x over root y. These facts are used in simplification of surds. In order to simplify a surd, the number under the root sign should be expressed as a product of two factors such that one factor is a perfect root. For example, simplify root 50. Root 50 can be expressed as a product of two factors. For example, 50 can be expressed as 5 times 10, but neither 5 nor 10 is a perfect root. So the best factors are 25 times 2. 25 is a perfect root. So we split it and have root 25 times root 2. The square root of 25 is 5, and so we shall have 5 times root 2, which gives us 5 root 2. Simplify root 3 over 9. This can be split up into root 3 over root 9. Then we shall have the square root of 9 is 3, and so we shall have root 3 over 3. That will also be equal to 1 over 3 root 3. Further examples, simplify the following: root 200, cube root of 250, root 450, and root 432. In our solution for the first one, root 200, we write 200 as a product of two factors such that one factor is a perfect root. The best is 100 times 2, and so we shall have root 100 times root 2. Square root of 100 is 10, and so we shall have 10 root 2. Next, cube root of 250. And so we express 250 as a product of two factors such that one of the factors is a perfect root. That is 125 times 2. The cube root of 125 is 5. Cube root of 2 is a surd. And so we leave it as 5 cube root of 2. Next, root 450. The best combination of factors is 225 times 2. Root 225 is 15 and root 2 is a surd. So we leave it as 15 root 2. And lastly, root 432. 432 is also the same as 144 times 3. So we split it, root 144 times root 3, and we shall have root 44 is 12 and root 3 is a surd. So we shall have 12 root 3. Conversely, a surd of the form a and the root of b can be expressed as a root of single compound numbers of the form and the root of a raised to n times b. And therefore, 2 root 5 is equal to root 2 squared times 5. That is equal to root 4 times root 5, which gives us root 20. Further examples express the following as roots of a single compound number: 3 root 7, 5 cube root of 2, 11 root 5, and 2 cube root of 5. In our solution, 3 root 7 is equal to root 3 squared times 7, which is equal to root 9 times 7, that is equal to root 63. Next, 5 cube root of 2 is equal to cube root of 5 cubed times 2. That gives us cube root of 125 times 2, and that is the cube root of 250. 11 root 5 is equal to root 11 squared times 5, which is equal to root 121 times 5, which is equal to root 605. Finally, 2 cube root of 5 is equal to cube root of 2 cubed times 5. That is equal to cube root of 8 times 5, and that gives us the cube root of 40. Order of surds. The index of the root of a surd is its order. For example, root 14 is a second order surd. Cube root of 9 is a third order surd, and fourth root of 64 is a fourth order surd. By expressing the given orders in their lowest common multiple, we can compare surds of different orders. For example, arrange the following surds in descending order: cube root of 19, root 23, and fourth root of 120. In the solution, the orders are 3 for cube root of 19, 2 for root 23, and 4 for fourth root of 120. The LCM of 3, 2, and 4 is 12. And therefore, cube root of 19 can be expressed as 19 raised to power 1 over 3. We need to make the denominator of the index 12. And so 19 raised to power a third is also equal to 19 raised to power 4 over 12. Notice that 4 over 12 is the same as 4 times 1 over 12. And so 19 raised to power 4 over 12 is the same as 12th root of 19 raised to power 4. And that will be equal to 12th root of 130,321. Next, square root of 23. This is also equal to 23 raised to a half. We make the denominator of the index 12. That is the LCM of the orders. And so 23 raised to power a half is also equal to 23 raised to 6 over 12. Notice that 6 over 12 is the same as 1 over 2. This gives us 12th root of 23 raised to power 6. That is equal to 12th root of 148,035,889. Finally, the 4th root of 120. 4th root of 120 is also equal to 120 raised to power 1 over 4. Make the denominator 12. 1 over 4 is also equal to 3 over 12. And therefore we shall have 120 raised to 3 over 12. And that is equal to 12th root of 120 raised to power 3. That gives us 12th root of 172,800. And therefore, the order is root 23 is the largest, followed by 4th root of 120, and the smallest is cube root of 19. Next, like and unlike surds. A surd such as a root b has two factors, the rational factor a and the irrational factor root b. Surds are alike if they have the same irrational factor, otherwise they are unlike. For example, 2 root 3 and 4 root 3 are alike because they have the same irrational factors root 3. On the other hand, 2 root 3 and 3 root 2 are unlike because their irrational factors are different, that is root 2 and root 3. Now, like surds may not always be clear. For example, root 27 and root 12 are like surds. That is because if we simplify them, root 27 is equal to root 3 times root 9. That will give us 3 root 3. Root 12 is also the same as root 4 times root 3, and that will give us 2 root 3. 3 root 3 and 2 root 3 are like surds because their irrational factor is the same, that is root 3. Like surds can be added or subtracted. For example, 5 root 3 minus 2 root 3. This can also be looked at as an equation. For example, if you had 5x minus 2x, where x in our case would represent root 3, then we shall subtract them directly and get 3x. So in our case, 5 root 3 minus 2 root 3 is equal to 3 root 3. Let's take an example. Show that root 18 and root 1 over 2 are like surds. We simplify them. Root 18 is the same as root 9 times root 2. That is the same as 3 root 2. On its part, root a half is the same as root 2 over 4. That gives us root 2 over root 4. That will give us root 2 over 2, which is also the same as a half root 2. And so the same are like because their irrational factor is root 2. Let's take an example. In this triangle, AB is equal to 5 centimeters, BC is 10 centimeters, and angle BAC is 90 degrees. Find the length of AC, leaving your answer in surd form. This is a right angled triangle, and according to Pythagoras' theorem, BC squared is equal to AB squared plus AC squared. Therefore, AC squared is equal to BC squared minus AB squared. That is 10 squared minus 5 squared, which will give us 75. AC is therefore root 75. That will give us root 25 times 3. Root 25 is 5. Root 3 is a surd, so we leave it as 5 root 3 centimeters. Multiplication of surds. Surds are multiplied in the same way as algebraic terms. The rational factors and irrational factors are multiplied separately. For example, 2 root 7 times 3 root 5. The rational factors are 2 and 3, so we multiply them separately. We have 2 times 3 times root 7 times root 5. 2 times 3 is 6, 7 times 5 is 35, and so we shall have 6 root 35. 4 root 2 times 3 root 3. That will be equal to 4 times 3 times root 2 times root 3. That will give us 12 root 6. Always simplify the surds before multiplication. For example, root 12 times root 18. Root 12 is the same as root 3 times root 4, which gives us 2 root 3. Root 18 is the same as root 9 times root 3, which gives us 3 root 2. And so we multiply 2 root 3 times 3 root 2, and we shall have 2 times 3 times root 3 times root 2, giving us 6 root 6. Note that for like surds, the product is always a rational answer. That is, root 5 times root 5 is equal to root 25, and that gives us 5. 2 root 7 times root 7. We multiply 2 times 1 times root 7 times root 7. Root 7 times root 7 is root 49, and root 49 is 7, and so we have 2 times 7, giving us 14. Let's take another example. 2 plus root 3 times 4 plus root 3. We expand just like we do with quadratic equations. And so the elements in the first bracket must be multiplied by all the elements in the second bracket. And so we shall have 2 times 4 plus root 3 plus root 3 times 4 plus root 3. Opening the brackets, 2 times 4 is 8. 2 times plus root 3 will give us 2 root 3. Root 3 times 4 will give us 4 root 3. And then root 3 times root 3 will give us root 9. Simplifying that, we shall have 8 plus 2 root 3 and 4 root 3 are like surds, and so we can add them. 2 plus 4 will give us 6 root 3 plus root 9 is 3. Collecting the like terms, we shall have 8 plus 3 is 11 plus 6 root 3. Next, rationalization of surds. Now we have already seen that the product of two like surds is a rational answer. This is called rationalization. When a fraction has a surd denominator, it is rationalized by multiplying both the numerator and denominator by a surd that will make the denominator a rational number. This way, we shall have rationalized the denominator. For example, rationalize 1 over root 7, 2 over root 5, and 3 over root 3. In our solution, 1 over root 7, the denominator is root 7. We rationalize it by multiplying both the numerator and denominator by root 7. If we do that, 1 times root 7 is root 7. Root 7 times root 7 is root 49, which is 7. Next, 2 over root 5. We rationalize by multiplying both the numerator and denominator by root 5. That will give us 2 times root 5 is equal to 2 root 5. Root 5 times root 5 is root 25, which is 5. Next, 3 over root 3. Again, we multiply both the numerator and denominator by root 3. That is, 3 times root 3 is 3 root 3. Root 3 times root 3 is root 9, which is 3. And we can cancel the rational functions. That is, 3 cancels with 3, and we end up with root 3. Lastly, 2 over 3 root 5. We multiply both the numerator and the denominator by the irrational part of the denominator, that is root 5. Notice that we are not multiplying by 3 root 5. That will give us 2 times root 5 is 2 root 5. 3 root 5 times root 5 will give us 3 root 25. That is 3 times 5, which is 15. And so our answer is 2 root 5 over 15. Now consider the following. Root 2 plus root 3 times root 2 minus root 3. Remember, in the difference of two squares, a plus b times a minus b was equal to a squared minus b squared. Therefore, expanding these surds, we shall have root 2 squared minus root 3 squared. That will give us 2 minus 3, which is equal to minus 1. Equally, if we had root 15 plus 7 times root 15 minus 7, we shall have root 15 squared minus root 7 squared. That will give us 15 minus 7, giving us 8. Surds whose product are rational are called pairs of conjugate surds, as the above. In order to rationalize surds with denominators of more than one term, we multiply both the denominators and numerators by the conjugates of the denominators. For example, rationalize the denominators in the following. In our solution, we simply multiply the numerator and denominator by the conjugates of the denominators. The first one, 3 over root 2 plus root 3. The conjugate of root 2 plus root 3 is root 2 minus root 3. And so we multiply both the denominator and the numerator by root 2 minus root 3. And we shall have 3 into root 2 minus root 3 over root 2 plus root 3 times root 2 minus root 3. We shall have 3 root 2 minus 3 root 3 over, following the difference of two squares convention, then we shall have root 2 squared minus root 3 squared. That will give us 3 root 2 minus 3 root 3 over root 2 squared minus root 3 squared. That will give us 2 minus 3, which is equal to minus 1. The second one, root 3 over 2 root 2 plus 3. The conjugate of 2 root 2 plus 3 is 2 root 2 minus 3. So we multiply this conjugate on the numerator and the denominator. Then we shall have root 3 times 2 root 2 minus 3 over 2 root 2 plus 3 times 2 root 2 minus 3. Then we shall have root 3 times 2 root 2 minus 3 over 2 root 2 squared minus 3 squared. We shall have on the numerator root 3 times 2 root 2 will give us 2 root 6. Then we shall have root 3 times minus 3 will give us minus 3 root 3 over, now the denominator, 2 root 2 squared will be equal to 2 squared is 4 times root 2 squared is 2. That gives us 8 minus 3 squared is 9. And so 8 minus 9 is minus 1. And therefore our answer is 2 root 6 minus 3 root 3 over minus 1.
I think one of the problems with math is if you aren't strong in it, you end up with weak spots in the foundation. And so if you want to build on that, if you want to go in and major in it or to do honors in it, you really do need a solid foundation. And so if you don't have it, if you've had a bad experience with math, you tend to sort of slough it off. And that's a serious mistake, I think. I believe with the right resources and help, most people can learn most of the math that they need to learn.